Hey guys, welcome to another video. Today, a question from the Extension 2 syllabus as part of the Nice Question series. Now, today's question comes from the Baulkham Hills 2024 trial paper. One of the last questions. It's in the topic of proofs, a nice 6-mark question, actually 2 3-mark questions to be exact, in today's lesson. So now, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends. All right, guys, let's dive right in. So I like this question because the first part looks and smells like a question from sort of the contradiction theory part of the topic, and then induction. So 3 marks piece sort of feels about right. So let's get stuck in, right? Prove that the part 1. Prove that the cube root of any irrational number, is also irrational, right? So I've got a cube root of irrational number. So cube root of any irrational number is also irrational, okay? And then let u equal to that. Given that is irrational, prove induction that u is irrational. Okay, I'll deal with that when I get there maybe. So for now, get stuck into part 1, right? So it goes, prove that the cube root of any irrational number. So maybe I'll define an irrational. So let n be, sorry, how do you write the q? Yeah, so how do you do it? Yeah, let it not be irrational, right? So basically let it be irrational. And, right? So the cube root of this is irrational, right? So, okay. So I have to say it's also irrational. And so prove that the cube root is irrational. Okay, cool. So I'm going to let this guy be irrational and then let the cube root be rational because I'm going to do contradiction. I'm assuming the opposite, right? So cube root, so the cube root of n, right, equal to also be rational. Yeah. Where cube root of n equals to p on q, where now, remember, every time we go rational, right, you should go pretty automatic about this, very textbook, right? 2 bullet points are, first point, right, p and q are integers, and p and q. Now, some schools let you write the words coprime. Some schools let you write, so don't let you, and then you have to write, they have no common factors, right? Same thing. So I'm just going to be lazy and write r coprime. Yep. Now, so I'm trying to basically get to a contradiction, right? Now, sometimes when you're doing these ones where it's square roots and stuff, you basically demonstrate that P and Q have the same factor. Generally speaking, it's like 2 or 3 or whatever, right? And then it's a contradiction. In this one, we're basically going to demonstrate that when you have one part is irrational, the other part is rational, it's contradiction, and that's what we're going to do. So let's see algebraically, cube root both sides, and you get n equals to p cubed. Let's write that better. On q cubed times this guy up. All right. Now, once we get there, we can sort of see that n is like, now, since n times q cubed is equal to p, then n must be a factor, right? Because they're all integers, right? Therefore, n is a factor of p cubed. Has to be, right? It's a factor. Now, herein lies the contradiction. Let me show you why. Yeah, I know, and I'll use colors maybe to help me. I know that n is defined as irrational. Yeah, has to be. I know that q, right, is rational, right? It's an integer, right? So q cubed is rational, right? Maybe you're rational. And also pq, so p cubed is rational, right? And that's the contradiction, because you can't have irrational multiplied by a rational to give you a rational. It doesn't make sense, right? So therefore, we can go, therefore, since, right, n is rational, right? That's part of my let upstairs, and q cubed is irrational, then nq cubed must be is irrational, right? Because when you multiply rational with irrational, it's irrational, right? Yeah. And then you go, therefore, contradiction, right? Because p cubed is rational. Yeah. So therefore, if the contradiction is true, then if there's a contradiction, then the negation are the opposite. So therefore, statement is true. Now, if your teacher doesn't like that, you can rewrite the question itself, but that's it. Yeah. Guys, how's that? So first part of this question, let n be an irrational number, because we know it's an irrational number. We're taking the cube root of it, right? So instead of, so some people look at this and go, wait a second, why did you let n be irrational and this guy be irrational, right? Because the question itself revolves around the cube root, right? That's really the cube root here. Yeah, you're not questioning the original irrational number itself. That's not part of your negation, right? Your negation is only on the cube root. Yeah, if the opposite case is only on the cube root. Once you do that, you prove that one side's rational, the other side's irrational, therefore contradiction. Pretty straightforward. Huh? All right, now let's do the next part. So let that, okay, given that, okay. Okay, it's straight induction. So let's do this. And what's my statement? Let that equal that, given that, prove that un is an irrational number. Okay, so my statement that I have to always prove is this, right, for every step. Yeah, so that's my statement. Okay, cool. So let me start this off over here and I'll move it up, right? So step one. Yeah, so in all positive integers, yep. So when n equals to 1. Yeah, let's explore that case. So u to the power of 1 equals to 5 to the power of a third, which is the cube root of 5, which is irrational. Yeah, which is irrational. Yeah, therefore, true for n equals 1. Simple. Right, cube root of 5, definitely irrational, no doubt about it. Next one, step 2. Now, we assume, right? We set up our assumption, assume n equals a k is true. Yeah, so that means that u to the power of k, which equals to 5 to the power of 1 over 3k, I think it is. Let me just check that. Yep. Is irrational. Yeah, I now need to demonstrate that n, so prove true, prove n equals a k plus 1 true, right? Which is u to the power, oh, u subscripts k plus 1, which is irrational. Yeah. Is that all right? So, okay, now let's see. Left-hand side. Right, so left-hand side equals to uk plus 1, which equals to 5 to the power of 1 over 3 now. Obviously, I have to get my assumption in, right? This guy here, yeah? I have to get that in somehow, right? That part there is irrational, okay? feels like then I need to split this fraction. So split the fraction into power. So 3k plus 3. Maybe I'll do that. Maybe I'll split by 1/3 and k plus 1. So bear with me. I think I did some. Just check that. Might have. Hold on, 3 to the power of k. Okay. We'll be very careful there, right? I wrote that wrong. Yeah, I wrote it wrong. 3 to the power of k in the denominator. Okay, give me 1 sec. 1/3 to the power of k, which means 1/3 to the power of k plus 1. Okay. I mean, that changes it quite quite dramatically. 3 to the power of k plus 1. Right, that's better. So if I go and try to split this, will be like 1/k times 3, right? All right, yep. And if I split that further, power of k times 1/3. Now that's good because that's like 5 to 1 on 3k. Well, sorry, 3 to the power of k to the power of 1/3. That's good because that is my assumption, right? Yeah, that's this, right? Which is irrational, right? So this part here is irrational, right? So I'm just going to go, that equals to UK. I'm going to sub that in, right, as my assumption to the power of 1/3. Now, from part 1, we know that any term that's irrational to having a cube root of it is irrational as well, right? So from 1, I can safely say that this guy here is going to be irrational, right? You go from 1. Yeah. Anything that's irrational to cube root is also irrational, right? So therefore, which is the right-hand side, right? I mean, you don't really, to be honest, this one here, the left-hand right side doesn't actually work. Yeah, it just means that, right? k plus 1 is irrational. So, and then step 3, yeah, by whatever sentence or paragraph your teachers want by principles of mathematical induction. Yeah, statement is true for n positive integers. Now, guys, how was that? So in this question, right, for the induction part at least, what you have to recognize is that, I mean, it's not hard, right? It's just different, right? Where step 1, sub into 1, we know that cube root of 5 is definitely irrational, right? No doubt about that, all right? That's easy. Step 2, set up your assumption where you basically say 1 on 3 to the power of k is irrational. And then when you try to sub in k plus 1, right, break down the fraction, split the fraction, and then we know that when there's a times in the power, that's like power to a power, right? So make the green part there to the power of a cube. Since the green part is irrational, part 1 says if there's an irrational number and I cube root it, it's also irrational. That's it, done. I like that. That's a nice question, how it ties in with part 1, 6 marks in a 4-unit paper. Nice, hard. Guys, if you like that, once again, like the video, subscribe to the channel, tell your friends. I'll see you at the next one. Thank you very much.